For this lab, we're going to be looking at the effect of the mass of an object versus the force of friction as it's sliding across the surface. The equipment that we'll be using are these little sleds, some assorted masses in order to increment the mass, a scale to determine the mass of your sled, your Chromebook, and then we're going to use the LabQuest to collect the data. In our last lab, we actually used the LabQuest to collect the data, and we read the data from the LabQuest. In this lab, we're just going to use the LabQuest as an interface to your Chromebook. Instructions on how to set that up will come up in a minute. But the first thing you want to do is set up, or actually just use the scale in the front of the room and find the mass of your friction sled. Once you have the mass of your friction sled, you can record that in your data table. Now, let's take a look at how we're going to go about setting up the Chromebook in order to take the data for this lab. To use the LabQuest as an interface to the computer, all we got to do is, one, turn it on, button over here, hook up your probe. In this case, this goes into channel 1, and then use this USB cord, come over on this side, plug in the USB cord, plug that into the USB port on a computer, and when you bring up your graphical analysis, it'll show that the LabQuest is the data acquisition device. So let's look at how we set up graphical analysis to take the data for this lab. So we want to open up your graphical analysis and choose sensor collection. Since I have the force probe hooked into the LabQuest, you'll notice that the force comes up, a force graph. That's exactly what we want. Now, the first thing we want to do is if you come over here, hit meter, and you'll see that I'm reading a force in the force probe. We don't want that. So what you want to do, with no weight or nothing on the force probe, just click in the red area here and zero it. There we go. Now our force probe is zeroed. Now you see that there's sometimes a little bit of force. That's just because air and things like that in the room affect the force probe because it's so sensitive. You want to make sure there's nothing hooked up or touching the force probe yet. And that it's also sitting nice and level on the desk, because if I tip it, it starts adding force. All right? Tip it the other way, it adds negative force. So I want it level on the desk and zeroed. All right, now that your sensor's set up, go back to one graph. There we go, we have one graph. Now that you have the Chromebook set up and the force probe zeroed, and we're set to graph 1, it's time to take some data. Remember, when you zero it, you have to go. Remember, when you zero it, make sure that the string is slack. You don't want to have any force in the force probe before you start. So all we're going to do is hook the force probe up to the sled, and someone will probably have to be on the other side over here. And get ready to go, and you're going to hit collect data, pull it at a nice, even, constant velocity. This is very important. If the velocity is not constant, your experiment won't work right. It can't be accelerating. You'll know that the velocity is constant because you should get a pretty even force. Now, it's going to jiggle up and down, but overall, it's going to average out to be nice and even. Okay, to start, we're going to hit collect, pull the sled across at a constant velocity, and stop. Now you'll notice several things on the graph. Well, right here you got a great big spike because that's where the sled initially accelerated. Now across here, the force probe is so sensitive that it's bouncing back and forth and back and forth. But this is actually pretty good data, even though it might not look like it. Then it drops off to zero again, pretty close to zero, when we hit the end. Now if yours doesn't drop off to zero, that's only because you kept pulling on the sled and kept having force in it when you hit stop or stopped collecting data. I actually, when I was done, pushed the force probe a little bit back toward the sled to make sure there was zero force into the cable. Now if your graph is too small or too large, all you got to do is hit zoom right there and it will zoom in on all the data. Now like I said, this data may look bad, but it's really pretty good.
The reason that we pull the friction sled at a constant velocity is because if you'll notice in our Newton's laws problems, if we have a constant velocity, that means that the net force is zero. So if the net force is zero, that means the force applied to the block by the force probe is also going to equal the force of friction. If we accelerate the block, then the force applied to the block will be greater than the force of friction, and it'll be very difficult and it will skew our results by quite a bit. Now, let's take a look at how we analyze one set of data. You'll notice that the graph data looks pretty rough, but when we apply the statistics function with the Vernier graphical analysis, it'll smooth out the data and we'll get a pretty good result.
Since we can't fit a nice curve or straight line to this, what we're going to do is we're just going to use the statistical function on the graphical analysis. So what do we want to do? We want to just highlight a nice section of data. Look at your graph tools, and then view statistics. If you look at the stats on this, I have a mean of 0.216, so that's my force. Now that's pretty good because if you look at this 0.016 for standard deviation, that's quite small. And so a very small standard deviation is going to tell us that our data actually fit the statistic quite well. So there's a trial, there's one run.
After your first trial, we'll do several trials just by incrementing the mass. Add another mass, and so on, until we've completed all of our data collection.
To do a second run, all you got to do is hit collect again, pull your sled at a nice constant velocity, stop it, there we go. And now I can take the stats a second time. View statistics. And you see that we have 0.31 newtons this time. That's because I incremented the mass when I took the next run. Again, my standard deviation, 0.043, quite small, so this is a very good statistical fit.